In the previous lecture, we have studied about minimization of DFA using the table filling method, also known as the Myhill Nerode Theorem. So in this lecture, we will be seeing another example where we will try to minimize this DFA using the table filling method. So if you don't know the steps that we have to follow in this method, I request you to watch the previous video before this before you proceed in this video in order to understand the steps. Okay, so let's get started and let's try to minimize this DFA using the table filling method. So the first step is to draw the table for each pair of states in this DFA. So let's draw the table for that. So here I have drawn the table for this DFA, and if you don't know why this table looks like this, watch the previous video to know why we have drawn the table in this manner. Okay, so now we have to check for the pairs of states in which one of the state is a final state and the other is not final state, and we have to mark those pairs. So starting with this, what is this cell? This cell stands for BA. So let us check for states B and A. B and A are both non-final states, so no need to mark it. And come to this, this is CA. C and A are also both non-final states, so no need to mark it. And then the next one is CB. C and B are both non-final states, so no need to mark. Come to this, this is DA, D and A, both are non-final states, so no need to mark. And come to this, this is DB, D and B, both are non-final states, no need to mark. And DC, DC are both non-final states, no need to mark. And come to this, this is EA, E and A. E is a final state and A is a non-final state. So this kind of pairs are the pairs we should mark. So let me mark this pair EA and then check the next pair EB. E is a final state and B is a non-final state, so I have to mark EB as well. And come to this, this is EC. E is a final state and C is a non-final state, so I have to mark this EC. And come to this one, this is ED. E is a final state and D is a non-final state, so I mark ED as well. So we have completed the first step in our procedure, and then coming to the next step, we have to look at the pairs which are unmarked in our table, and for each pair we have to check where does the state pairs go on particular inputs and check if the pairs that are generated by that are marked or not, and accordingly we have to mark them or keep them unmarked. So let us check that. So coming to this one, this is the first unmarked pair, which is BA. So let me check for state BA. So let's see where does B go on getting input 1 and where does A go on getting input 1. So B on input 1, it goes to D, and A on input 1, it goes to C. So we get this pair DC. Now check if DC is marked. DC is not marked, so no need to do anything. Now I have checked for the inputs 1. Now I have to check for inputs 0. B on input 0, where does it go? It goes to B itself. And A on input 0, where does it go? A goes to B. So we get this pair called BB, and we see that there is no cell for BB. There is no BB in this table, so you don't have to do anything for this. Now come to the next one that we have to check, the unmarked pair. This is CA. C and A. Now let me check. Let me first start with 0 in this here. C on getting input 0, where does it go? And A on getting input 0, where does it go? So C on input 0, it goes to B, and A on input 0, it goes to B. Again we get the pair called BB, which is not there in our table, so no need to do anything with it. Now check for the input 1. C on input 1, where does it go? And A on input 1, where does it go? So C on input 1, it goes to C itself, and A on input 1 also goes to C. So we get a pair called CC, which is again not present in this table, so no need to do, like we can leave it. Now we have checked for CA, and the next one is CB. Now let me do it over here. CB. On input 0, where does C go? And where does B go on input 0? So C on input 0, it goes to B, and B on input 0, where does it go? It goes to B itself. So we get a pair called BB, which is again not there in this table, so we can leave it. And then let's check for inputs 1. C on input 1, where does it go? And B on input 1, where does it go? So C on input 1 goes to C itself, and B on input 1, where does it go? It goes to D. Now we get a pair called CD. Now check if CD is marked. Where is CD? This is CD. CD is not marked, so we don't have to do anything. Now let us continue the same procedure. Let's come to this. This is DA. Now as I do this, you look at the transition diagram and try to figure out how it is being done. D on input 0, it goes to B, and A on input 0, also it goes to B. So BB, we get this pair which is not there in the table, so we can leave it. And then D on input 1, it goes to E, and A on input 1, it goes to C. We get the pair called EC. Now check if EC is marked. EC, yes, EC is marked. Now since EC is marked, I have to mark this DA. So let us mark this DA. This is DA, and we mark it. Now let's come to the next one. We should check for DB. Now let me check for DB. Where does D go on getting input 0? It goes to B. And where does B go on getting input 0? It goes to B. So BB is not a pair in the table, so no need to do anything. Now let's check for inputs 1. D on input 1, where does it go? It goes to E. And where does B go on getting input 1? It goes to D. Now we get a pair called ED. Now check if ED is marked. ED, yes, ED is also marked. Now since ED is marked, I have to also mark DB. So let me mark DB. This is DB, so it is marked now. Now let us come to the next one. The next one is DC. So I'll write it here. DC. For DC, D on getting input 0, it goes to B, and C on getting input 0 also goes to B. And since BB is not a pair in our table, no need to do anything. Now let's check for input 1. D on input 1, it goes to E, and C on input 1, it goes to C itself. So we get this pair EC. Now check if EC is marked. EC, yes, EC is marked in our table, so I also have to mark DC, which I checked just now. So DC is also marked. Now I have completed the first iteration for this second step. So how do we continue? We have to repeat these steps for all this set of unmarked pairs until we find that no more new markings can be made. So here we still have 3 unmarked pairs, so let us check for them again. The first one being BA. So BA, let's see, where do they go? On B on getting input 0, it goes to B, and A on getting input 0 also, it goes to B. We get this pair BB, which is not there, so no need to do anything. And B on getting input 1, where does it go? It goes to D. And A on getting input 1, where does it go? It goes to C. Now check if DC is marked or not. DC, yes, DC is marked. Now since we found that DC is marked, I have to mark this BA as well. So let me mark this BA. Where is BA? This one. I mark it over here. Now let us continue. Let us do for this pair, which is CA. So let me write it here. CA. C on getting input 0. Where does it go? It goes to B. And A on getting input 0. Where does it go? It goes to B. So BB is the pair we get, which does not exist in the table, so no need to do that. Now let's check for the next input, that is C on input 1. It goes to C. And A on input 1, where does it go? It goes to C itself. So the pair we get is CC. So CC is again not existent in our table, so no need to mark this. So we completed CA. Now let's come to CB. So I'll write it here, CB. So C on getting input 0, where does it go? It goes to B. And B on getting input 0, where does it go? It goes to B. BB is not a pair in our table, so no need to do anything. And C on getting input 1, where does it go? It goes to C. and B on getting input 1, where does it go? It goes to D. So we get the pairs CD. Now check if CD is marked. Where is CD in our table? CD means this one. DC and CD is the same thing, so this one is marked. Now since this one is marked, I have to mark the pair CB as well. So let me mark CB. Where is CB? This is CB and it is marked. Now we completed the second iteration again in the second step. Now we find that in the table, if you look here, this is the only unmarked pair now, and this is the only one we need to check in the next step. So let us just check this step for this pair, that is the pair of CA. So let me check it here. CA, C on getting input 0, where does it go? It goes to B. And A on getting input 0, where does it go? It goes to B. And BB is not a pair in our table, so no need to do anything. Now let's check for input 1. C on getting input 1, where does it go? It goes to C itself. And A on getting input 1 also goes to C. And we get this pair CC, which is not there in the table, so no need to do anything. So we find that we have done all the markings, and now no more new markings can be made. Now how much ever you continue, this will be the only table you get, and the only unmarked pair is CA. Now let us see how we can make the minimized DFA using this. So what we have to do is we have to combine the unmarked pairs. So we saw that CA was the unmarked pair, so I can also call it AC. CA and AC is the same thing. So A and C, I combine them and I make them as one state. And what were the remaining states? B, D and E. So these are the remaining states that I have. So let me copy down our original DFA here so that we can see how we can minimize it using these new states that we obtained. So here is our original DFA, and then I have to combine the states AC. A and C can be now combined and made as a one state, and then the rest of the states are B, D and E. Now let us try to draw the transition diagram for them. AC is a single state as we got, and AC will be the initial state. Why? Because A was the starting state in the original DFA. And then we have a state called B, let B be here, and then we have another state D over here, and then we have E over here, and E was the final state, so E will remain the final state even in this one. And then how do we make the transitions? We see that A and C both on input 0, it goes to B. So our new state AC on getting input 0, it will go to B, and on getting input 1, A is going to C and C is also going to C. That means on getting input 1, AC will stay in itself. Okay, so that is a transition, and then the rest of them will remain the same. B goes to B itself on getting input 0, and B goes to D on getting input 1. Okay, and D, where does it go? D goes to B on getting input 0. So we'll send D to B on getting input 0, and D goes to E on getting input 1. So D goes to E on getting input 1, and what is left? State E. E on getting input 0, it goes to E on getting 0, where does it go? It goes to B. So let us send E to B on getting input 0, and on getting input 1, where does E go? E goes to C. That means it should go to AC. So on getting input 1, E goes to AC. So this is the minimized DFA that we have obtained. So in the original one we had 5 states, and here we have 1, 2, 3, 4 states, and the state that we could combine was AC. Why? So if you look at the table, AC was the pair that was unmarked, so the unmarked pair is the one that we need to combine and minimize the DFA. So I hope this example was clear to you. Thank you for watching, and see you in the next one.